Hi, I'm Keo Plays. What is dry ice? Let's figure that out.
Of course we have an intro. Come on. Roll it.
Yo, the science guy. Yo, the science guy.
Science rules.
Yo, the science guy.
Shitting is a property of matter. Kill. To the Tuba mansion.
Yo, the science guy.
A lot of this is gonna be voiceovered because I am terrible in front of a camera, off script. So, yeah.
So according to Wikipedia, dry ice is the solid form of carbon dioxide. It is commonly used as it does not have a liquid state and sublimates directly from the solid state to the gas state. It is used primarily as a cooling agent, but it's also used in fog machines as theater for dramatic effects. Fun fact, the meaning of sublimate is to change form. Physically speaking, it means to change a solid into a vapor. In this case, solid dry ice into CO2. So now here comes the tough part. What can I possibly do in the next couple minutes that's even worthy of being a part of Tuba's science fair? And so here I am, pacing and thinking, clearing a table, until it finally hits me.
So, I guess you could say we did a couple of egg experiments.
So, fun fact, so my dad knows a guy that knows a guy, yada yada, that has a surplus of eggs, so that's where I got it from. And we ran a couple of experiments. We tried freezing an egg on top of dry ice, and all that really did was leave an imprint, as well as some other things. We tried putting in water, and that didn't do shit, but with the dry ice sitting on top of it, it did crystallize the egg. Long story short, we got nothing. So here's a video of me eating ice cream. So now, using what we know about sublimation, about the fact that it could turn straight from a solid into a gas, we could gather the fact that we can speed up the process by exposing it to warm water, because it's already undergoing that form change at room temperature. So by allowing hot water to come into contact with it, we're allowed to speed up the process. And in this case, we use that information to blow up a balloon. But here's the problem with that, is that before the experiment even started, the balloon started to tear and hurt my hand. And so we kind of had to scrap that project too. And so experiment number 2 failed. But with that failure led us to experiment number 3, and that was to start turning dry ice into little foam bubbles. And so here I am adding hot water, and we got a step in the right direction. So I would say that's a little bit of a pass, but I know we could go bigger than that. So what if I hypothetically took a vacuum hose and had one end feed into the ice smoke and one into a bubble, and we got a little bit of step, but the dry ice wasn't funneling directly into it. So idea number 2 was to get a water bottle, and this one worked way better. So I'm just gonna shut up and let you guys see what happened. So I may have messed around with this explosive hazard. In simpler terms, gas makes pressure, pressure makes boom. Due to the rapid emission of large volumes of CO2 gas, the dry ice that's stored in a closed container can be pressurized. Given enough time at normal room temperature, the container may explode if the gas is not able to escape.
In conclusion, science.